Okay, so now we're on Unit 8, KA. So let's get started. So number 1, it says no matter what the base, an exponential function of the form f of x equals b to the power of x always goes through the points. And that is 1b and 0, 1. Okay, so what that kind of looks like is this. We'll have an exponential graph that looks something like this, and it will always have the point 0, 1 and 1 b. So for example, if I have 2 to the power of x, okay, that b, that would be 2. Okay, so number 2, okay, we're going to label the graphs. We have f of x equals 2 to the power of x and g of x equals 9 to the power of x. So we're going to use that definition that we just learned to determine which graph is which. To start with f of x. So remember, exponential graphs have the point 0, 1 and 1 b. Let's do 2x first. So b here is 2. So we're going to have the point 0, 1 and 1, 2. So 0, 1 is right here, and then 1, 2 is right here. So this one's going to be f of x. Okay. Oops. And then g of x equals 9 to the power of x. So the points are going to be 0, 1, and then 1 b. Here b is 9. So 0, 1, which is here, and then 1, 9, which is all the way somewhere up here. That's most likely this graph. Okay, so that means that A is B, and this one's B. Okay, so number 3, for an exponential function, f of x equals A times B to the power of C times x, changing the value of A will change the y-intercept. Number 4, for an exponential function, f of x equals A times B to the power of C times x, changing the value for C will change the base. Okay, so for example, if I had 2 to the power of 2 times x, well, right here, we should know what that is. What's 2 squared? 4 to the power of x. So the base changed. It went from 2 to 4. Okay, so number 5, make sure you have your calculators. It says Gabriel invested $4,500 at 4% interest compounded quarterly. How much money would he have after 6 years? And then this is the formula we're going to use. Okay, so let me go ahead and go over what is what. So P stands for the initial amount. So the amount you start with. R represents the interest rate. So the interest rate, and you're always going to write it as a decimal. And then N represents how many times it's compounded in a year. Okay, and then what else do we have? We have T, which represents time. And in this case, it's going to be the number of years. And then capital A just represents the final amount. So what you end up after T time has passed. Okay, so I'm gonna go ahead and start with A equals. And we know that Gabriel started with 4,000, so that's our P. That's our P there. R is our interest rate, which is 4%, and then you write that as a decimal. It tells us that it gets compounded quarterly, so that means 4 times in a year, so N equals 4. And then how many years? 6. So I'm gonna go ahead and plug in those values. So 450, open parentheses, 1 plus 0.04 divided by 4 to the power of 4 times 6. Okay, I'm just gonna clean it up just a little bit, and I'm just gonna multiply those exponents here. 4 times 6 is 24. Okay, and then what you're gonna do, you're gonna type this entire thing right here into the calculator. Okay, so type that into the calculator exactly as you see it with an exponent of 24. And once you do that, you're gonna get 5,713 and 81 cents. All right, so number 6, your Terbium decays 50% every 4.2 days. How much of an 80-gram sample would be left after 54.6 days? And this is the formula we're going to use. It's an exponential. So we have E there. And let's go ahead and label what each letter means. So A sub 0 stands for the initial amount. E is the value. Okay. So it's not a variable, like it's not X. It's like pi. You know how pi is 3.14? E is 2 point something. Okay, and then K represents, again, the interest rate or the rate. Again, you write that as a decimal. And then T represents time. And in this case, it's going to be days. And A, again, means the final amount. Okay, so here we have our decays 50%. So that means K equals 0.5 every 4.2 days. 80 is our initial. And they also give us, or they're asking like how much would be left after 54.6 days. So we need to first calculate time, T. And since erbium decays every 4.2 days, so we're going to take 54.6 and divide it by 4.2, and you're going to get 13 days. So that's our T. So now we're ready to plug in our value. So A equals 80 times E to the power of negative 0.5 times 13. And again, you can type this exactly into the calculator. Okay. Okay, and then once you do that, you're going to get 0.12 grams. Okay, so number 7, they want us to fill in the chart. And then if we need to round, we're going to round to 1 decimal place, which is the 10th place. Okay, so basically what they want us to do is plug in the x values to find our y's. So they did 0 for us. 1.5 to the power of 0 equals 1. And then let's go ahead and do 1.5 to the power of 1, which is 1.5. And that is letter B. Okay, now we're going to do 1.5 to the power of negative 1, which is about 0.7. Okay, so when you type that into the calculator, we're just rounding to the 10th place, and that's letter L. Okay, now we're going to do 1.5 to the power of 2, which is about 2.3 when we round it. That's letter F. Number 4 is 1.5 to the power of 4, which equals to 5.1, and that's letter O. Okay, and then the next column, they just want us to write them as coordinate pairs or points. So again, they did the first one. When x is 0, y is 1. Now when x is 1, we have y is 1.5. Negative 1, 0.7. 2, 2.3. 4, 5.1. Okay, and then let me go ahead and tell you which letters that is. So that's A for this one, E, H, and K. Okay, so last column. So the last column, they want us to do the inverse. So remember about inverses. X and Y switch. Okay, so that just means like if X is 0 and Y is 1, they're gonna switch. You see how they switch positions there? Okay, so the new X is 1.5, new Y is 1. That is letter C. Then we have 0.7, negative 1, and that is G. 2.32 is I. And then 5.1 to 4 is D. Okay. Okay, so let's look at number 8. So number 8, it says the number y, so that b to the power y is x, is called the logarithm. And what's happening there, so if we start with y equals base of x, this is exponential. And so if they switch, if x and y switch, and then we try to solve for y, well, to solve for y, we have to take the log of the same base here. This will cancel, and then we're left with y equals log base b of x. And that is called the logarithm. That is, these two are inverses of each other. Inverses of each other. All right, so let's look at number 9. The base of the logarithm function. So there's a rule about with logs, the base cannot equal to 1. Okay, so number 10, it says complete the table. So there's one rule that we need to know to help us do this, and that is if the base of the log is the same as the logarithm and there's an exponent, what happens is that these cancel and you're left with x, or the exponent, and you write it as a regular size number. Okay, so let's look at this first one. So we are given log base 4 of 1. Okay, so I need these two to be the same. that's 1, but I do know that 4 to the power of 0, because anything to the power of 0 is 1. So I'm going to rewrite this as log base 4 of 4 to the power of 0. These are the same now. They cancel. We're left with that exponent 0, which is letter B. Okay, so let's look at 4. Log base 4 of 4. If you don't see an exponent to a number, that exponent is understood as 1. So these now cancel. We're left with 1, which is letter A. Okay, now we have log base 4 of 16. So what do we know about 16 and 4? Well, if I square 4, I get 16, right? 4 times 4 is 16. So I'm going to rewrite 16 as 4 squared. These cancel. I'm left with 2, and that is letter G. Then we have log 4 of 1/4 here. And so one thing we need to remember is that if we have a number with a negative exponent, like a negative 1, what happens is that number flips. Oops, like that. Okay. So for example, if I have 2 to the negative 2, or not put 2, let's put a letter A to the negative 2, that becomes 1 over A squared. Okay, and then vice versa. So that's basically what we're going to do here. So we're going to make this log sub 4 of 4 to the negative 1. Okay, and those cancel, so we're left with negative 1, which is D. And then we're going to do the same thing here. So this becomes log 4 of 16 to the negative 1. And then what do we know about 16? 4 squared. So log base 4 of 4 squared. And then we have to multiply that negative 1. So that gives us log base 4 of 4 to the negative 2. Those cancel. That equals negative 2, which is letter E. Nice. All right, so number 11. It says if log base of 3 equals 1.10 and log base B of 6, equals 1.79, then log B base B of 18 equals what? Okay, so for this one, you need to know the product rule. Okay, and what the product rule states is that if you have a logarithm with some base and we have a product, you can split that up to where they're going to have the same base, but one goes here, the other one goes there, and then you add them. Okay, so what do we know about 18? So we know factors of 18 include 1 times 18, 2 times 9, 3 times 6. So 3 and 6 seem to match because that's what they gave us. So log base B of 18 is 3 times 6. And then we can split those up to log base B of 3 plus log base B of 6. And so we know that this is 110 and this one is 1.79. Add those up, and what do you get? You get 2.89. Okay, so let's look at number 12, it's similar. They give us givens, but we're looking for this. So for this one, you need to know the quotient rule. And the quotient rule states that if you have a log with some base and you're dividing inside, you can split them up to where they're going to have their own log of the same base. And the x or the number in the numerator goes first, and then it's the denominator, and then you subtract. So we have log 5 over 2, which is 5 over 2. And we're going to separate them as log 5 minus log 2, which is 1.6 minus 0.7. Okay, and when you subtract those, what do we get? What is 1.6 minus 0.7? Okay, you should get 0.9. Okay, so 13. To shift the graph of f of x equals a plus c times log of b, we change the parameter g. Okay, what happens? Okay, so I'm going to go ahead and rewrite this one. So we have a times log base b of x minus h plus k. Okay. And basically k is a vertical transformation, and you're either going to go up and you'll see plus, or down, and then if you see a minus, h here is a horizontal transformation, and you're either going to go left where you'll see a plus, or you're going to go right and you see a minus. And then A is also a vertical transformation. It's either going to be a shift, not shift. It's either going to be a stretch or a compression. Okay, so if G is G is the H, it's going to move horizontally. Okay, and then, so it's the same thing. What did we change? Parameters A, D. So let's look at A right there. It's a vertical transformation. Okay, so 15. Describe which way, up or down, and by how many the graph will shift. Okay, so let's do the general a times log of base b of x minus h plus k. So remember, a is a vertical transformation. It's going to be a stretch or a compression. H is a horizontal transformation. You're going to go right if you see minus, or left if you see plus. And then K is also a vertical transformation. You're going to go up if you see plus, and then down if you see minus. Okay, so let's look at this one that they gave us. I'm going to rewrite it so it looks similar to what we have. So f of x equals log of x minus 10. So we have one transformation, and it's outside here. It's outside parentheses, so that is our k. And we are going which direction? Well, it's minus, so we're going down, which is A. And how much are we going down? We're going down 10, which is C. Okay, so same thing here. Let me go ahead. Never mind. Okay, so notice here we have ln. So ln is the natural log, and that is just log with a base of e, and you just write it as ln. Okay, so let me go ahead and write the general graphing form. So we have a times the natural log of x minus h plus k. So remember, k is a vertical transformation. You're either going to go up if you see plus or down if you see minus. A is also a vertical transformation. It's going to be a stretch or compression. And then H is a horizontal transformation. You're going to go left if you see plus or down if you see minus. Okay, so again, I'm going to rearrange this one. So f of x equals the natural log of x minus 3 plus 7. And so we have two transformations here. We have one inside the parentheses and one on the outside. Okay, so the one on the outside, okay, it's a vertical transformation. Since it's plus, we're going which way? We're going up. And then how many times are we going up? 7 times. So A is, where's up? C. 7 is H. Okay, and then minus 3, it's inside, so it's a horizontal transformation. And since it's minus, we're going to the right. And we're going to the right 3 times. So that is D for B, and then D, as in dog, is G. Okay, and then last one. Okay, choose the correct graph that sketches these two. So if you remember anything, or if you have less than or equal to or greater than equal to, your graph is going to be a solid line. So we can already cross this one out since it's dashed. That one's solid, and then we can cross that one out. Okay, so now what? Well, let's go ahead and start with our 5 to the power x, our exponential. Remember that first definition, number 1, where it states that exponentials have the points 0, 1, and 1, b. Okay, so here b is 5. So we're going to have the point 0, 1, and 1, 5. So let's look at for those. So 0, 1, and 1, 5. So this one's a possibility. Let's check this one. 0, 1, 1, 5. This one's also a possibility. Okay, so now let's do our ln of x plus 4. And what do we know about logs and exponentials? Well, they're inverses of each other. Okay, so remember, logs are inverses. So they have, if exponentials have 0, 1, logs are going to have 1, 0. And if exponential has 1b, logs have b1. Okay, so let's go ahead and make a t-chart since this one has a transformation. So x over y. And remember, since it's inside the parentheses, it is a horizontal transformation. It's plus, so we're going to the left. And since we're going to the left, we're going to subtract 4 from x. Okay. So let's keep that in mind, and then let's think about what points that would. Okay, so we know that every log has 1, 0. So when x is 1, since there's a transformation, we're going to subtract 4 from that. So 1 minus 4 equals negative 3, and then y is 0. So that's 1 point. And then b1. Well, what is b to the natural log? Remember, Natural log is just a log with a base of e. So e1. And so we're going to do e minus 4, which e is about, or minus 4 is about negative 1.28, and y is 1. Okay, so let's look for those points. So we have negative 3, 0, and then negative 1.28, 1, which is about there. So that one's a possibility. And then again, 3, 0, and then negative 1.281. So not this one. So this is our answer right here. Okay, so right quick, let's go ahead and go through the answers that we should have. Okay, so number 1, there's 2, it should be 1b and 0, 1. 2 is b and a. 3 is y-intercept. 4 is base. 5 is 5,713 and 81 cents. 6 is 0.12. 7, so we go down the columns, B, L, F, O, A, E, H, K. And then third column, C, G, I, D. 8 is logarithm. 9 is 1. 10 is, if we go down, B, A, G, D, E. 11 is 2.89. 12 is 0.9. 13 is horizontally. 14 is vertically. 15 is A, C. And then 16 for the first column. So A is C right here, or B is D, and then C is H, and then D is G. And then 17 is this graph. Okay. So, and that's it.